This last video is just a little bonus piece of content. There's a quick summary in the slides if you want to follow along there as well. It gives kind of a walkthrough of the practice problem that we did in an earlier section. But I just want to quickly show you how you can do what we just did in Excel. So you can do this by hand. It is just going to be the same principle, but let me just walk through how to do this find the standard deviation in Excel by hand. So I'm just going to create a random string of numbers. So in Excel, if you want to use a formula, you start off with an equal sign. To create a random set of numbers, I'm going to use the command rand between, and this is telling Excel, hey, come up with a random number between a certain range. So I'm going to do between 1 and 10. So I'm telling Excel just come up with some random number between 1 and 10. So it comes up with 8, and I'm going to drag this down and just do a set of 10 numbers. It updates every time that you kind of make a move. So what I'm going to do is just copy and paste this as a number. And so now it's no longer a formula, it's just a set of numbers. Let me actually zoom in a little bit here. Okay, so I have a random set of numbers between 1 and 10. So I can ask Excel to find me the mean. And here I'm going to use the equal sign to say I'm doing a formula and then ask for the average. I do a parenthesis and then I can select my range. And I always want to close off that parenthesis and it'll calculate the mean for me. I could also get this by summing all of these scores and dividing it by 10, but asking the Excel for the average is a little bit easier. So I have my average. Now I need to find the deviation scores. So again, I can use the equal sign to let Excel know that I'm doing the formula, and I can take B2, this particular score, and subtract the mean. I do that, and what I see is my score is 2.6 points below the mean. Now I could do that for each of these. I can also use, this is a nice little handy time saver. You can actually put a dollar sign in front of any part of the equation to basically lock it in here. So if I put the dollar sign in front of the 13, it's basically saying like, hey, lock in this row 13. So real quick, just let me show you. If I don't do that and I drag the formula down, it's going to basically drag the columns down with it. But if I put the dollar sign in front of the 13, not a pound sign, a dollar sign, it's going to say, hey, lock into this particular cell. I could also put it in front of the B to extra double lock it in, but I'm not dragging across, so it should be fine. So now I should be able to, if I hover over this little symbol here, this allows me to drag the formula down. And now what I see here is it's taking B2, or this one's taking B2, the number in B2. This one's taking the number in B3 minus the mean. This one's taking the number in B4 minus the mean. And so just really quickly by doing that, I got all of my deviation scores. So you can see some things are, quite a bit below the mean. There's a couple things quite a bit above the mean. But we have our deviation scores. Now I can get my deviation score squared. So again, I do the equal sign. To do a square, you could either do like multiply by the same thing, or you can do the little caret symbol to the second, and this will square your value. So again, I can do the principle where I hover over this little corner, my cursor turns into a plus, and I can just drag the formula down. And it's basically saying, hey, go find whatever's in the cell next to it, square it, and we get the value. And of course, we can see here, things that are super close to the mean, when I square them, they're kind of teeny tiny. The ones that are farther away from the mean have a higher value. So now what I can do is I can find my sum of squares, which is just the sum of those deviation scores squared. So I can just add them all up. The little key for this is sum. And I want to put a parenthesis so that I can specify a range. And I just say all of these guys here. So what I'm doing is telling Excel, add up everything in this range, click enter, and I get a sum of squares of 68.4. Now I can do my variance, which is just the sum of squares divided by n. I'm going to pretend like this is a population of scores. So we would have 10 here. So I'm going to divide by 10, should get 6.84. And then finally, my standard deviation is the square root of the variance. So the little code for square root in Excel is SQRT. And then I need to specify what cell I'm taking the square root of. So in this case, it's G5, which is where my variance is living. I click enter and I get the 2.61 with some, rounding 2.62 or so. So if I were to actually just do the formula for it, I'm doing a population, so I'm using var.p. If I were to find the variance for this random set of numbers that I came up with, you can see it's the same thing that we found by hand. So same thing for standard deviation, for a population, we get the exact same thing. So that's just, I sometimes find it nice to kind of break down, we can do it super simple. We can get it through Excel or JAS very easily, but it is kind of nice to see like, that simple little this that we did. It's really doing all these calculations behind the scenes. So if you're doing this yourself and you can kind of understand, it makes these numbers that we're coming up with seem a little bit more familiar. I'll also add real quick. So say we were doing the sample. So if you remember the sample, it's going to be the exact same, except instead of dividing by the total number, we're doing the number minus 1. So in this case, 10 minus 1 is 9. And again, we're just taking the square root. Now, if we were to do just the variance, both Excel and JASP actually just assume that you're doing the sample, variance, and population. So the default is that. But again, you see that it's exactly the same formula, or the same numbers as we got by doing it by hand and then just using that little shortcut. So hopefully that's a little bit interesting. That's, a easy way to do it without having to necessarily write each number out by hand, but still really being able to break down what's going on with these formulas that as we get further into statistics